Soil and waste drainage system. This is now our topic. So ito yung soil and waste. Ito yung water closet, lavatory, floor drain, at ito yung mga sink, sa equipment. So papunta dito sa main or septic tank. So itong isa is grease trap galing sa kitchen sink. Kasi yung mga mantika dyan, di ba? Yan, saluhin niya dito, iiwanan yung lana, ang mantika. Then, yung tubig na lang kasama. Fixture traps, tunan natin to. Ito yung importante sa drainage. A fixture trap is a fitting or device which provides a liquid seal. Liquid seal kasi ito, liquid to, water, which will prevent the back passage of air without materially affecting the flow of sewage or wastewater to it. So dito yung air. Acceptable fixture traps must have the following characteristic. A, must be self-cleaning. B, must have superior interior. C, must have no movable parts or partition. Must have a minimum seal of 2 inches. The tawag doon is trap seal. Must have an accessible clean out. This one. Ang tawag dito is feed trap. Yan ang allowed lang. This one is trap arm. Hanggang doon sa bend. Ito. Ito yung picture trap. Ito yung trap arm. Ito yung drain. Yung distansya nito, ang tawag dito sa ano is ground weir. Ito yung level niya. Okay. This is the outlet. Outlet to nung galing dito. Punta doon. Ay hindi, baliktad. Ito pala. Punta dyan. So dito yung hangin. Ito yung takpan kasi. Yung tailpiece, ang tawag dyan ng yung port, yung connection dun sa fixtures mo. Okay, meron siyang adapter. Kasi normally ito, meron 1 half, 1 port. Ito is 2 inches. 2 inches ang minimum sa drain pipe available. So, prohibited traps. Ground vented traps and traps which depend upon movable parts for their seal are prohibited. A trap is considered to be ground vented when the vent is within 2 pipe diameters of the weir. So ito yan, incorrect ground vent. Ito yung correct vent location. Dapat 2 pipe diameter distansya. This proximity of the vent to the surface of the water in the trap tends to foster evaporation of the seal as the air circulates in the venting system. If a fixture is not used over an extended period of time, it is possible to lose the water seal due to evaporation. Ito yung correct. Trap seal. Ano ang trap seal? Ito yan. Trap seal is the maximum vertical depth of liquid that a trap will retain. Yan. Measured between the crown weir, ito, and the depth of the trap. Tandaan niyo yung mga tawag dyan. A trap must provide a minimum seal of 2 inches. All drainage and venting systems are designed so that the pneumatic pressure variation in the system are limited to positive 1 inch to negative 1 inch of water column. So, total of 2 inches. So, pag bumaba to ng 1 inch at taas to ng 1 inch. Sabihin niya. Next, flow and drainage piping. So, ito yung mga flow. Ito yung halimbawa, ito yung septic tank mo. Ito yung main. So, bago pumunta dito, meron kang septic tank. To store yung mga drainage mo. Kasi para yung mga galing sa water closet mo ipon dito. Flow. Tapos meron siyang manhole access sa paglinis. Okay? Gravity flow and sloping drain. Sa lahat yan naka-slope. It is mga 2, sa baba, 1%. O sa iba, pag may mga 3 inches and below is mga 2%. 4 inches, 6 inches is 1%. 0.5% pag 8 inches and above. Ang diameter. Okay? Basahin nyo na lang dun sa plumbing code. Hindi lahat yun may discuss dito. When flow occurs and rain piping, it does not entirely fill the pipe under normal conditions of flow. If the pipe were too full, pressure fluctuation would occur, which could possibly destroy the seal of trap within the building. So kaya dapat di siya puno. Gravity flow and sloping horizontal rain lines of a plumbing system is similar to the flow of water in open channel. Okay? Mayroong inclusion na horizontal kasi mayroong naka-slope siya pero considered as horizontal. Pag more than 45 degrees is that is vertical. Flow in open channels is not dependent upon a pressure applied to the water, but it is caused by the gravitational force induced by the slope of the drain and the height of the water in that drain. Fluid mechanics nyo. So uniform flow. Uniform flow is that flow which is achieved in an open channel of constant shape and size and uniform slope. The slope of the water surface that then matches the slope of the channel. Manning formula in English system is B is equal to 1.486 over N times R is equal to 2/3 times S 1/2. Well, B is the velocity of flow in feet per second. N is a coefficient representing roughness of pipe surface, degree of fouling, and diameter. May table yan. R is the hydraulic radius, hydraulic mean depth of flow, and feet. S is the hydraulic slope of surface of flow in feet per foot. Yeah. Then the quantity rate of flow is equal to the cross-sectional area of flow times the velocity of flow. This can be expressed as Q as AB, where Q is equal to quantity rate of flow and cubic feet per second. A is the cross-sectional area of flow and square feet. B is the velocity of flow and feet per second. So English yun yan. So pagdating sa SI, pwede mo rin gamitin. Except dito sa constant, mag-iiba. So pag ito ginamit mo, pwede mong i-convert sa feet. Tapos, velocity mo common feet per second. So convert mo na lang to meter per second. By substituting the value of B from the Manning's formula, we obtain Q is equal to A times 1.486 over N times R exponent 2/3 times S exponent 1/2. So the hydraulic mean depth flow R is usually called the hydraulic radius is the ratio of the cross-sectional area of the flow to the weighted perimeter of the pipe surface. Consider half. Ito yung weighted perimeter. Ito yung liquid, water. So yan. So the hydraulic radius is the area ito divided by the weighted perimeter. So that is the equation for R. This slope is ito, delta Y over delta X. Then value of S, this slope of the surface of flow, and S and 1/2 are tabulated in table 1 for the most common slopes of drainage piping employed in plumbing system. Common slope. Table 1, values of S equal and S and 1/2. So for a slope on in inches per foot, sa 1/8, yung slope mo is 0.0104. So madali lang yung convert. So S is 0.1/2 is 0.102. So 1/4 inch per foot is 0.0208, 0.144. Then 1/2 is 0.04186 and 0.204 ang S is 0.1. So remember, in percentage, this is 1%, 2%, this is 4% slope. Okay? Kita nyo, times 100. This is now 1%, 2% is slope, 4% is slope. Kasi minsan gagamitin natin is ito in inch per foot or meter per meter or percent. Recommended values of N for use in the design of plumbing sanitary drains are, so pipe sizes, 1 and 1/2 N is 0.012, 2 inches to 3 inches is 0.013. 4 inches is 0.014. 5 inches and 6 inches is 0.015. 8 inches and larger is 0.016. Take note, sa atin, gagamitin natin lang is 6 inches. So, 1, 2, 1 and 1/2, 2, 3, 4, and 6, then 8 and larger. Sa standard sa okay, meron 5 inches sa standard list, pero sa Pilipinas, mahirap pag-stock ng 5 inches. Automatic for 6. Kapag nag 5 inches ka, mas mahal, baka mas mahal pa sa 6 inches. Kasi nga, mahirap mag-stock niya. Mahirap mag-stock niya, diba? Okay. So, 8 inches, ano sunod? 10, 12, 14, 16, 18. Yan, walang 11. So, this is for plumbing sanitary drain. Sa storm drain naman, a value of 0.0545 can be safely employed for all sizes and pipe. Okay. Ito yung galing sa bubong. Scalding action. In a drain pipe, the lifting or scrubbing of those particles, including sand, grit, and small pebbles, from the interior of surface of the pipe and carrying them downstream. To achieve this, sufficient flow velocity is required. This is called scalding action. So para mahila mo yung mga buhangin sa baba, pipe, di ba, may mga laglag yan. So para maisama mo yun sa flow, meron siyang sufficient flow velocity, that is minimum. Yan. Yung maximum is na yun sa limit nun is para sa noise friction. So the minimum velocity of flow to achieve scalding action in piping is 2 feet per second. Yan. Pag bumaba ka dyan, so mag-sacrifice na yung may iwan. Sand, grit, pebbles, and other foreign matters which are held in suspension in the wastewater will begin to deposit in the pipe when velocities fall below 2 feet per second. A minimum velocity of 4 feet per second is required to maintain greasy waste in suspension. Yan naman, pag may mga mantika o greasy yung waste mo. Minimum velocities are obtained by proper sizing and slope of pipe. An examination of table 2 and 3 reveals that several of the pipe sizes yields velocities less than 2 feet per second. It is for the reason that runs of 1.5 and 2-inch pipe must be held to a minimum length so that the intrust velocities will maintain the minimum required scalding velocity for this short distance involved. So ito yung table 2, uniform flow velocity and capacity of sanitary drains at 1/4 inch per foot slope. We have 5 sizes is 1/4, 2%. Ito yung standard. So 1 and 1/2, 2, 2 and 1/2, 3, 4, 5, 6, 8. So tanggalin yung 5. Sandli saka 2 and 1/2. Okay. So selection natin. Para silikan ng 5, tanggalin mo kung 2 and 1/2 saka 5. Kasi available sa market, walang 2 and 1/2 na DWB, drain, waste, and vent pipe material. Okay. So full flow andito, may mga velocity, half flow, full velocity, ito. Full flow velocity capacity, ito siya. Ayan. Yung formula niya, ginamit ito. Ayan. QSA as 1.486 over n times r squared 2/3 times exponent 1. Yan din yun. So table 3, velocity naman. So this is for storm drain, table 3. And this is for sanitary drain. Di ba binanggit dito? Yan. Ito yung sa storm drain. Next, soil and waste stock. Alin yun? Ito yun. Soil stock, waste stock. Waste stock, galing lang siya sa mga laboratory o basin. Pag galing sa toilet, soil stock. Pag ito, nag-merge dyan, ito, kinunik ko rin dito, tawag pa rin dyan is soil stock. Stock is a general term for any vertical line of soil, waste or bent piping, which collect water and waste from texture drains and horizontal bands from 2 or more floors of a building. So, ako sa vertical, tawag stock. Ito mga horizontal na to, ang tawag yun is mga branch or main. This does not include vertical texture drain and branch vent that do not pass through more than the 2 stories before being reconnected to the soil or waste stock or vent stock. So, biro nagbabypass dyan ng vent. So, hindi kasama niya. The wastewater comes from water closet, urinals, lavatories, bathtubs, showers, sinks, and various other fixtures. A soil stock collects waste which contain fecal matter, such as water closet and urinals. A waste stock collects waste which do not contain fecal matter, such as sinks, lavatories, bathtub, etc. So, ito. Diba? Soil stock, galing lang sa water closet. A waste stock collect waste that contain fecal matter. So, pero pag nag-mix siya, ang tawag na rin doon is soil stock. Stock connection, paano makakabit yung mga branch mo. So ito, meron tayong sanitary T, meron tayong TY. Saan ginagamit yan? So the horizontal branch connection to this stock are made with sanitary T, horizontal branch. This is a short radius TY. Ito long radius, ito short. With a T or with a TY which has a long radius. So ito yung isang mahaba. This fitting direct the waste in the stock with an initial downward velocity, which permit the stock to accept an increased rate of flow at any level. The TY gives the water a greater downward component than the sanitary T, and hence is more advantageous for greater stock capacities, but is less favorable due to tendency to create a self-siphonage of the friction tap connected to the branch. The TY is often called combination Y and 1/8 bend. The sanitary T can be used only in vertical position, whereas the TY may be used in vertical or horizontal position. Yan ang pagkaiba na ito. Kaya pa nag-take up ng materials, nakita mo sa plano, dito lagi yung sanitary T. Yung mga nag-connect sa stock. Now, for the flow and stock, the character of flow of water and partially filled vertical pipe, vertical sipin yan, vertical yan, varies with the extent to which the pipe is filled. For a small volume of flow, amounting to little more than a trickle, the flow is entirely on the inner wall of the stock. Dito yung flow niya. So ito sa gitna hangin. With the increase in volume, this adherence to the wall continues up to a point where the frictional resistance of the air causes it to diaphragm across the pipe temporarily, forming a short slug of water, which descends as a slug filling the stock until the increased air pressure breaks too. So the water forming the stock either being thrown against the wall or falling a short distance as separate streamlets in the center of the pipe. The diaphragming and forming stock probably first appear in a 3-inch stock when the stock is from 1/4 to 1/3 full. This intermittent rate partially accounts for the rapid erratic oscillation of pressure in the planning system. From this, it can be seen that a stock should never be designed for a capacity greater than 1/3 full. Otherwise, the pressure fluctuation in the system could greatly exceed plus or minus 1-inch column of water pressure criterion, and traps could possibly lose their seal by siphonage or blowout. Now, terminal velocity and length. So when the plumbing engineer is called upon to design the systems for a very tall building, he is invariably asked how he is going to accommodate the extremely high velocities developed at the base of the stacks. Diba naman, sa taas ng building, pagdating sa baba, mataas yung velocity, diba, yung gravity. So, hindi yun totoo sa plumbing kasi may pipe, may pipe. So, how is he going to prevent the base fitting from being blown out or broken? Diba, sira daw kasi naka-pressure. This is one of the oldest and most persistent myths in the plumbing profession, and unfortunately, is still believed by too many uninformed designers. So, depending upon the rate of flow from the branch drain into the stack, the type of stack fitting, diameter of the stack, and the flow down the stack from the upper level, the discharge from the branch may or may not entirely fill the cross-section of the stack at the point of entry. As soon as the water enters the stack, it is immediately accelerated by the force of gravity, and in a very short distance, it forms a sheet around the inner wall of the pipe. The sheet of water with a core of air in the center continues to accelerate until the frictional force exerted by the pipe wall on the falling sheet of water equals the gravitational force. From this point downward, provided no flow enters the stack as the sheet passes a lift fitting, the sheet of water will fall at a velocity which remains practically unchanged. Hindi na bibilis. This ultimate vertical velocity is called terminal velocity, and the distance in which this maximum velocity is achieved is called the terminal length. Diba? Meron tong topic sa MLab. Ganyan din. Makuha mo yung terminal velocity. Hindi ko alam kung anong testing niya. Limot ko na. Pero meron tong topic sa MLab. The formulas developed for terminal velocity and terminal length without going through a complicated calculus are V sub t is equal to 3.0 times Q over D exponent to third. L sub t is equal to 0.05 to B sub t exponent squared, where B sub t is the terminal velocity in the stack feet per second. L sub t is the terminal length below point of entry feet. Q is the quantity rate of flow, GPM. T is the diameter of the stack. So dito sa figure, ito yung length naman mula dito sa entry and entrance. Kaya terminal length, yung terminal velocity, yung distance yan. So this is the formula for SI. Pinapya ko lang ito sa Google, Internet. So ito yung, hindi ko na pinalitan to. Ito kasi SI to. Applying the formulas for various size pipes, it is found that the terminal velocity is achieved at approximately 10 to 15 feet per second, and this velocity is achieved within 10 feet to 15 feet of fall from the point of entry. The importance of this result is that it conclusively destroys the myth that water falling in a stack from the great height will destroy the fitting at the base of the stack. So the velocity at the base of 100-story stack is only slightly insignificantly greater than the velocity at the base of 3-story stack. So yan. Stack capacities. Ano yung capacity ng each pipe size? The flow capacity of a stack can be expressed in terms of the ratio of the cross-sectional area of the sheet of water to the cross-sectional area of the pipe when the flow down the stack is at terminal velocity. These lags of water and the resultant violent pressure fluctuation did not occur until the stack flowed 1/4 to 1/3 full. The maximum permissible flow rates in the stack can be expressed by Q is equal to 27.8 times R exponent 5/3 times D exponent 8/3. So Q is the capacity in GPM, R is the ratio of the cross-sectional area of of water to cross-sectional area of the stack. So, itong sinasabing 1/4 full to 1/3 full, yan na yung ratio niyan. The diameter of the stack. So, values of flow rates when R is 6/24, 7/24, and 8/24 are tabulated in table 4. Ayun 6/24 is equal to 1/4. 8/24 is equal to 1/3. 7/24 is equal to 7/24. Yan. So, makikita nyo yan sa table 4. So, maximum capacities of the stack, 5 chances, 2, 3, 4, 5, 6, 8, and 12. Never mind 5. Ito yung mga flow in GPM niya. Okay? Yan yung value. So, most code authorities have based their stack loading tables on a value of R as 6/24 or 7/24. The upper limit of R is equal to 8/24 is very rarely used due to real probability that diaphragm will occur with the resultant problem. Dito na lang walang pinipili o normally is comfort. O average is, ito kasi sa gitna is yung average ng 1/4 and 1/3. Okay. Hydraulic jump. At the base of the stack, flow enters the horizontal drain at a relatively high velocity when compared to the velocity of flow in a horizontal drain under uniform flow conditions. For a 3-inch stack flowing at capacity, the terminal velocity is 10.2 feet per second. For a 3-inch drain installed at a stop of 1/4 inch feet per foot, the velocity under uniform flow conditions at full or half full flow is 2.59 feet per second. When the water reaches the vent at the bottom of the stack, it is turned at right angle to its original flow, and for a few pipe diameter downstream, it will continue to flow at a relatively high velocity along the lower part of the horizontal drain. Ganyan. Varies to approximately 10 times the diameter of the stack. So yan ang ano niya. This is called hydraulic jump in a horizontal drain. So ito mabilis. Ito mabagal. Dito mabagal siya. So parang yung alon, yung wave. Diba? Mabagal so ito mabilis. Since the slope of horizontal drain is not adequate to maintain the velocity of water that existed when it reached the bottom of the stack, the velocity of the water flowing in the horizontal drain slowly decreases with a corresponding increase in depth of flow until a critical velocity is reached when the depth of flow suddenly increases. This increase in depth is often great enough to completely fill the cross-sectional area of the pipe. This phenomenon of sudden rise in depth is called the hydraulic jump. The critical distance at which the hydraulic jump may occur varies. It is dependent upon the entrance velocity, depth of water which may already exist in the horizontal drain when the new flow is introduced, roughness of the pipe, diameter of the pipe, and the slope. The distance varies from immediately at the stack fitting up to 10 times the diameter of the stack downstream. Less jump occurs if the horizontal drain is larger in size than the stack. Increasing the slope of the horizontal drain will also minimize the jump. After the hydraulic jump occurs and fills the drain, the pipe tends to flow full. Large bubbles of air moving along the top of the pipe fill water. Surging flow conditions will exist until the frictional resistance of the pipe retards the flow to the of uniform flow conditions. Any offset of the stack greater than 45 degrees can cause a hydraulic jump. Next, drainage system. So, sewage disposal sa labas. Wherever a public sanitary sewer or combined sewer are available for disposal of sewage from building, the sanitary drainage system of the building must be connected to a public system. So, meaning, meron siyang centralized ng septic tank. Parang malaking septic tank ka. Hindi ka na maglalagay sa iyo. Meron ng mga lugar na ganyan. Pero sa atin dito, required is individual septic tank kasi wala tayong centralized. Sa Manila, meron ng mga lugar doon. Availability of public sewer is usually defined by the municipality and can vary from 100 feet to 500 feet and greater. Ang layo. Whenever it is practical to do so, it is recommended that connection be made to public sanitary or combined sewer as the most economical method of sewer disposal. Where public sewer are not available, an approved private sewage disposal system must be provided. Yun na yung mga septic tank, STP. Sewage treatment plant. Okay. This private system must conform to all the rules and regulations of all authorities having jurisdiction in that locality. Ito yung authority having jurisdiction. Ito yung mga pwedeng official sa engineering, municipal engineer, yan, sa DNR, engineer ng DNR, ng mga nag-evaluate, dole, nag-evaluate ng mga plano, sila ang mga authority having jurisdiction. Pag may pinagawa, require yung mga building official, gawan mo lang ano to, lagyan mo ng plumbing, bawa. So maghanap sila ng master plumber, nagagawa ng design. Pipirma, design, tama. Pero i-evaluate yun ng building official. Pag kulang, papadagdagan nila. Pag sobra, depende sa kanila kung papaalisin nila. Okay? Pero gano'n, sila ang masusunod kasi authorities. So, the sanitary drainage system should never discharge onto the ground, and it should never discharge into waterway until it is treated and rendered harmless. So the sanitary drainage system should never discharge into the public storm sewer. So hindi pwede magsama yun. The storm water is not treated, and any discharge of sanitary waste in the system could contaminate other wastewater resources. So yung magaling sa ulan, mayroong sariling linya yan, iwalay na linya, tapos doon mo sa discharge, sa dagat, sa ano, may kadiring, may sariling ano yan, line. Okay, itadirect mo lang sa mga kanal. Stormwater disposal, ito yan. Every building must have adequate provision for draining water from roofs, paved areas, courts, and yards. Paved areas yung sementado. Yung may, ano kayo, yung bayan, may, yung mga sementadong garden, may bakod. So, sa labas ng bayan, sementado, so kailangan ng paved doon. Pero kung ano yun, lupa, huwag na. Kaya nga, paved area, courts, and yards. The stormwater drainage system should connect to the public storm sewer or combined sewer. The storm drain should never be connected to the public sanitary sewer. When the public storm or combined sewer are not available, stormwater may run to an existing stream or an adequate system of dryways. So drainage system below sewer level. Yung mga may basement. Where a drainage is below the elevation of the house drain, which drains by gravity to the sewer or the public sewer, the discharge should be conveyed to a sump or ejector and pump or automatically lifted up in the gravity drainage system. So yung mga basement, yung level ng kalsada mo, siyempre, taas. So yung drainage nyo, iipunin mo yon tapos ipapump mo, punta doon sa main. Okay, ang tawag doon, sump pump or ejector pump. So, yung topic na to is hindi natin isama dito. So, subject, concentrate tayo sa piping. Same, pump sizing na naman to. Sump are uses to handle clear water and need not be airtight and vented. Ejectors are used for sewage and must be airtight and vented. Okay. I-elevate mo siya. Next, backwater valves. So kung wala kang sariling septic tank, so i-discharge mo siya sa main. So, kailangan mo ng backwater valve para hindi bumalik, pumasok sa system mo, yung sa building mo, yung mga galing sa kapitbahay mo. Diba? There is often the danger of backflow of passage into a building when the public sewer becomes overloaded or is surcharged. To prevent backflow and possible flooding of the building, a backflow valve should installed in the drainage piping from all fixtures which are at an elevation below the surcharge level of the public sewer. Kung mataas yung public sewer mo sa baba, so kailangan mo ng back. So ito, protective plumbing full port backflow valve. This is your sewers from your home flows safely out to the city's sewer line. So normal flow ito, city sewer. So pag ano siya, open siya, di ba? Sewage and reverse causes the backflow gate to close, preventing city's sewage from coming up in your basement. Balik siya. So magsasara siya. So hindi papasok ng mga dumi sa kabila. Okay? So ibira pa sa atin to. Kati ang septic tank man. Mahal din yan. Kaya minsan ayaw nila. Mahirap dito. Pag ayaw, doon ka na tumakbo sa building official. Palang building official doon. Pag inakbayan sa tapos na. Pag mahigpit, sunod yung kliyente. Okay? Piping installation. Horizontal piping must be installed in alignment, parallel to walls, and at sufficient pitch to assure a minimum velocity of 2 feet per second. To attain this minimum velocity for scoring action, a minimum of pitch of 1/4 inch per foot should be employed for all pipe 3 inches and smaller in diameter. Ayan. So this is 2% slope. A pitch of 1/8 inch per foot for larger pipe is a factor to maintain an adequate velocity in the piping. So this is now 1% slope. Diba? Kaya nga yung iba, yung main is 4 inches. Malaki. Kahit kinumpute mo, siya, sa 3 inches lang. So, kung nag-compute ka, nag-compute mo 3 inches, ilalagay nila 4 inches. Kasi 3 inches, ang slope niyan, 2%. Kung halimbawa, 30 meters yung ano mo, so ilan yung slope nun? So, meron kang 0.600 mm. 30 meters, 2%. So, 600 mm. Yan yun. 24 into feet. So, kung sa ground, mag-uukay ka ng 2 feet sa dulo. So, kung sundin mo yung 1%, sa palakyan mo ng 4 inches, magiging 1% sunsuan, nagkala. 1 foot lang. So, hindi malalim yung kakayan mo. Okay? Kasi minsan, lalo sa mga kisame naman, so, 30 meters. Pagdating sa dulo, tumama na sa pintuan mo yung isang pipe. So, kailangan, palakihan mo yung pipe para maging 1% ang slope. So, drainage, 90 degrees elbow, trap, sanitary T's and T-wise are all tapped at a pitch of 1/4 inch per foot to provide proper pitch to the horizontal pipe when transferring from horizontal to the vertical position. Yan lahat. Itong mga sanitary fittings, sanitary pipe fittings, hindi yan parehas ng ordinary pipe fittings. Kasi ito, meron pang mga pitch, ka-slope siya. Eh, kung makikita mo, kumuha ka ng standard elbow, sa elbow na pang sanitary, tabingi yung sa sanitary. So, piping above ground in the building should be securely supported from the building construction. Piping should never be hung from ductwork. Tinabad na, kinabit na lang mo sa ductworks or other piping. Inserts, rods, hangers, wires, and anchors should be of durable material, giving adequate strength to perform their function. So, maximum spacing between support for various piping materials are, so cast iron. So, horizontal, simply at every fitting and every joint. Vertical, so every story. Kailangan may support ka dyan. Screw piping, simply every 12 feet. Vertical is alternate floor. Bakit alternate po? Ito story. Kasi square piping is 2 inches and below. Maliit lang. DW copper, horizontal, drain waste and copper to a dito pipe. Every 10 feet for 2 inches and larger, and every 6 feet for smaller sizes. Vertical, so every story kasi malambot to. So, there can be no greater length than 2 feet from the vent connection for any future drain outlets. So, kung meron kang abang, dapat maglagay ka ng 2 feet. If this maximum distance is not observed, a dead end is created in which fungi, slime, and sludge can collect. The only exception to this rule is where it is necessary to extend the piping for clean out to an accessible location. Yeah. Itong exception na to, kung 2 feet, yung clean out mo 3 feet, so hindi ka naman mag-extend na. So, clean out, okay yun. Kasi nabubuksan naman yun, di ba? Hindi naman mapupuno yun na ganito, mga slime, sludge. Kasi nga, clean out. Doon ka papasok na lilinis. Ito. So, tinatawag na plug outlet sa vent saka sa drainage. Clean outs. Clean outs are provided. Ito, ang clean out, bubuksan, may takip yan, bubuksan mo, lagyan mo yung auger wire. Ito yung panundot para matanggal yung mga blockage na dumi. So, these are provided in piping to permit access to piping for clearing of stoppages without the necessity of dismantling or breaking the piping. The size of clean out should be the same size as the piping up to 4 inches. For larger pipes, larger size piping, 4 inches clean out are adequate and for their intended purpose. Clean out should be provided at the following location. 1. Inside the building at the point of exit. Use a Y branch or a house flap. 2. At every change of direction greater than 45 degrees. 3. Maximum distance of 50 feet should be maintained between the clean outs for piping 4 inches and less, 100 feet for larger piping. Underground piping larger than 10 inches in diameter should be provided with manholes at every change of direction and every 150 feet. Or at the base of all stacks if accessible. Kasi dapat ito nga sabi is all clean outs must be accessible and where necessary should be extended to the floor or wall. Adequate clearances must be provided around the clean out for the manipulation of equipment in rodding out stoppages of them. Okay? So minsan wala ito kasi di accessible. So hanap ka ng ibang location. So ito, clean out. So may clean out pa dito, so okay rin yan kasi pwede mo ito galawin. Pero pag hindi siya accessible, dikit na to, so okay na yan. Meron ka na clean out dito. Dito mo na buksan, pasok mo yung auger dyan. So ito naman yung mga standard detail, pagkabit ng clean out. Itong isa, ceiling clean out. Itong isa, floor drain clean out. Floor drain. So mali itong isa. Okay, wait.